Hi and welcome to this revision lesson on energy changes, part of the GCSE physics course. Okay, so the first thing you need to know is what a system is, because we will often refer to systems when we talk about energy transfers, and a system is an object or a group of objects. And when a system changes, the way that energy in the system is stored changes. So I'd like you to have a look at the questions, pause the video and have a go at answering them. What are the energy changes when a ball is thrown upwards, a car drives into a wall, a shopping trolley is accelerated by someone pushing it with a constant force, a lorry decelerates, or water is boiled in an electric kettle? Okay, so when a ball is thrown upwards, the chemical energy that was stored in the muscle of the person doing the throwing is decreased. In the first instance, that energy is converted into kinetic energy of the ball, but then that's transferred again into the gravitational potential energy of the ball. So the GPE of the ball increases, but some of the energy also goes into the thermal energy, the heat energy in the ball and the air. So the thermal energy store of the ball and the air also increase. Okay, when a car drives into a wall, there we're starting off with the car having kinetic energy. So the kinetic energy of the car is going to decrease, and that energy is going to be transferred into the car and surroundings, so the wall, the ground, etc., and the air around it, as thermal energy. So the thermal energy stores of all those things is going to increase. Okay, when a shopping trolley is being accelerated by someone pushing it with a constant force, well, again, we're starting off with the chemical energy in the muscles of the person who's doing the pushing, and that chemical energy is going to decrease, and that's being converted into the kinetic energy of the shopping trolley. So the kinetic energy of the shopping trolley increases, and again, we've got some thermal energy being produced as a waste, so the thermal energy store of the trolley and the surroundings is also going to increase. Okay, when a lorry decelerates, again, we're starting with kinetic energy. So the kinetic energy of the lorry is going to decrease, and that once again is going to be converted into thermal energy, and that thermal energy is being produced and stored in the brakes and in the wheels and in the road surface. There'll also be some thermal energy in the surroundings. And finally, when we're boiling water in an electric kettle, we're starting off with electrical energy, so the electrical energy decreases, and that is being converted into thermal energy. Now, the useful thermal energy in this case is the thermal energy in the water, but we've also got waste thermal energy going into the materials of the kettle and the air surrounding it. So we've got thermal energy stores of water and the surroundings increasing. Okay, what is the equation for kinetic energy? Pause and write it down. Okay, you should have got that kinetic energy is equal to half times mass times velocity squared. Okay, so kinetic energy is measured in joules. Half is obviously just a number. Mass is measured in kilograms and velocity in meters per second. And it's really important that you remember that the velocity is squared, and only the velocity is squared. So don't forget that. Remember, you've got to memorize this equation for your exams. One that you don't need to memorize is the equation for elastic potential energy, which is equal to half times spring constant times extension squared. The elastic potential energy is measured in joules, the spring constant is measured in newtons per meter, and the extension is in meters. Make sure you're using the extension and not the length, so the extension is the change in length. Okay, what's the equation for gravitational potential energy? Pause and write it down. You should have said that GPE is equal to mass times gravitational field strength times height. Again, GPE is measured in joules, like all types of energy. Mass is measured in kilograms. Gravitational field strength in newtons per kilogram. And height is measured in meters. Okay, on Earth, the gravitational field strength is 9.8. If you're asked about anywhere else, they will give you the gravitational field strength. Okay, change in thermal energy is another equation that you will get given. So change in thermal energy is equal to mass times specific heat capacity times change in temperature. The change of thermal energy, it's an energy, it's in joules again, mass in kilograms, specific heat capacity is in joules per kilogram degree Celsius, and change in temperature in degrees Celsius. For the specific heat capacity, you also need to know the definition, and specific heat capacity is defined as the energy required to increase the temperature of 1 kilogram of a substance by 1 degree Celsius. So you need to memorize that definition. Last thing to go through in this session is power. And power is defined as the rate at which energy is transferred or the rate at which work is done. I'd like you to pause for a moment and write down the equation for power. Now there are two equations for power. The first one is power is energy transferred divided by time taken. And power is measured in watts. Energy transferred is measured in joules and time is measured in seconds. The alternative equation is power is equal to work done divided by time taken. Again, power in watts, work done is in joules, and time is in seconds. So 1 watt is 1 joule per second. I hope this has helped. I'll see you next time.